the limits of functions. Okay, limits of functions. The concept of limit is super important in calculus. So because everything in calculus is defined in terms of limits. Okay, I'm going to write a slogan in here. Okay, you remember a slogan. Before we introduce the concept, you just remember the concept of limit. The concept of limits is fundamental in calculus. It's fundamental in this course, in any calculus. Okay. In the sense that it's because that I can probably say almost everything. Can I just say everything? Everything. Actually, it's everything. It's defined. Everything in calculus is defined in terms of limits. You are going to have better understanding of the slogan while you learn the course. The central concept in calculus is kind of the derivative, so differentiation. But the derivative is defined in terms of limits. You are going to see probably in lesson 2 weeks. And then another key thing is integration. The integrals, any integral is defined in terms of limits. You are going to see at the end of the course. Okay. That's why I say the concept of limit is fundamental in this course, in calculus. Actually, in any calculus. The key idea is to use limits to handle infinity. Wherever you actually see infinities, you have limits. Later on, you are going to have better understanding of what I just wrote in here. Okay. I'm going to give the definition first. Okay. These definitions are, I said, informal. For the people who are not going to do math major, so probably you do not need the formal definition. But for the people who really want to do the math major, which I rarely see people who really want to do math major. Okay, for the people who really want to do math major, you need the formal definition. But we do not talk about the formal definition. We only talk about the informal definition. Okay. Actually, the definition I'm going to write for you is more informal. It's more informal than what you see on the screen. I will give you a more informal definition. Okay, easier to understand. After the more informal definition, I'm going to make some comments. Okay, so that you can deal with the concept. You can deal with some limits. Okay. I will give you a more informal definition. Okay. Can I just write more informal? More informal. Okay, now I'm going to define the meaning of the following notation. Okay. I will write the condition first. Okay. Given a function, so just copy it down. Okay. I will make more comments later. Everything is going to be clear. So, given a function, so now let's say f of x defined at a number defined that all numbers close to 8. Okay. Defined that numbers, all numbers close to close to, now let's say, x value of a, the number a. So just copy it down. Very shortly, I'm going to make more comments. Okay. I'm going to define the meaning of this notation. After you copy the notation, I want you to remember how to read it first. So very shortly, I'm going to tell you the meaning. Okay. But before I tell you the meaning, I want you to know how to read the notation first. So listen to me carefully. So probably you want to write it on your notes. Okay. How we read this? This notation, we read this notation, the limit of the function f of x as x approaches a from the right. I want to repeat the notation. It means the limit of the function as I. Now let me try again. Now let me restart. Okay. This notation is the limit of the function f of x as x approaches a from the right. The limit equals a number L. I will give you a very informal definition. This notation means, can I write some means in here? Means very informal. Okay, very informal. It's probably the repeating notation. You just you just try to listen to what I'm saying. It means the function f of x approaches the number L as x approaches a from the right. Just treat that as a very informal definition. Okay. I gave you a very informal definition, so because I'm going to make more comments. The more comments, so we'll make the whole thing clear. I hope I have enough space to make more comments. So can I start from here? I will make more comments on the same screen so you can compare what's in the informal definition and what the comment is. Write everything down. Everything is going to be clear when we do questions. Okay. Now comments. I'm going to make a few comments. Okay. So the limit of the function as x approaches a from the right is determined by, I'm going to write four things, and probably three things. We'll see four things or three things. The limit of the function as x approaches a from the right is determined by, one thing is the values of the function not at a. I mean not at a. So just copy it down. Eventually you are going to see the limit of the function as x approaches a from the right has nothing to do with the value of the function at a, no matter it's defined at a or not. So just remember that. Okay. You're going to see it very shortly. Everything is going to be clear soon. Secondly, the second comment, the limit of the function is determined by the values of the function not at a. I did not write anything wrong. I just found out there's a better way to write it. Okay, the limit of the limit of the function as x approaches a from the right is determined by the values of the function f of x. I'm going to start the list from here. Okay, the first one is not at a. Secondly is greater than a. Or you can say to the right of a. So that's why we say the limit of the function as x approaches a from the right greater than a. Or you can replace that as with something like to the right of a. Thirdly, very close to a. Fourthly, getting closer and closer to a. I told you I would write 4 things. I think I wrote 4 things. That's what I wanted to write. Okay. Write this down first. So very shortly we are going to see a particular question showing you how to get the limit of the function using a list of values. Okay. I told you to download handout number 2. Actually, I'm going to go over question 1 on handout 2. Okay. We'll do that first. So because I gave you the right hand side limit first, I'll go over the right hand side limit first. Okay. I know many of you guys are confused at this point, so don't worry, it's normal. Okay. After we go over at least one question, everything will be clear. Okay. Okay, in this question, so first of all, I want you to know how to read the question. Okay, how to read the limit. The whole thing is called the limit of the function. I'm not going to read the function. The limit of the function as x approaches 1 from the right. I will introduce a notation of the function. Okay, I'm going to use f of x to denote the function. F of x is the function x minus 1, x squared minus 1 on denominator. Okay. The first thing we're going to do is not officially how to evaluate the limit. The following way is intended. The following way is designed to understand the concept of the limit. Okay, it's designed to. Okay, now you look at the question on the handout. Okay, we're going to identify the limit using a list of values. In particular, I want you to use a list of 4 values. Okay. To list the values, in most cases, I want you to form a table. Okay. To form a table, so something like this. 2 columns, a table with 2 columns. In the column to the left, you write x to mean in this column. In the first column, can I say first column? In the first column, you choose a list of x values. And then the second column, the column title is probably f of x. Okay. Okay. Now let's recall what I commented earlier. The limit is determined by the values of x at numbers not equal to 1, right? To the right of 1, by that we mean bigger than 1, very close to 1, getting closer and closer to 1. I will use the table to show you the meaning. Okay, to show the meaning. Can anybody tell me one particular number that is greater than 1, or to the right of 1? To the right of 1, it means on the number line to the right of 1. Okay, The origin is here, and to the right of 1. So 1 is here. So tell me, yeah, 2 is pretty close to 1, but I want a number. Okay, so why not? Okay, eventually the numbers are going to be very close to 1 anyway. 2 is one particular choice. Choose a decimal number, please. Closer to 1. To the right of 1. Closer to 1, please. Can I use 1.1? Yeah, 1.5 is okay. But I want to start with 1.1. So sorry. So because I have handy values of the function, you could start with 1.5. It doesn't matter. Okay. But eventually the numbers you choose are going to be getting closer and closer to 1. So yeah, that's the idea. Okay. The first number to the right of 1 and very close to 1, I want to use 1.1. So sorry. You could use 1.5 and then you get some other closer numbers. And the second number I want to repeat. The limit is determined by the values of x very close to 1 to not equal to 1. In particular, not equal to 1. You cannot choose 1. It has to be greater than 1. Okay. The first number I chose is 1.1. The next number, so can I choose the next number? So 1.01. The number after that, I want to use 1.001. Okay. Can I use the next number? Now let's say 1.001. 0001. Okay. Limit. Okay. I want you to get your calculator to tell me the value of that function at 1.1. As long as you know how to get one value, you should know how to get other values. So please, now I want you to evaluate the function at 1.1. So by that we mean you plug the value I lost my color. You plug the value of 1.1 into the function. I want you to compute 1.1 minus 1. On denominator you have 1.1 squared minus 1. So please, I want you to be able to evaluate that function at least. Anybody want to tell me the value of the function very quickly? So maybe run to a few. At 1.1 should be defined. At 1 is not defined. At 1.1 is defined. Try again. The function is only undefined at 1 and -1. So maybe round to a few more decimal places. Yeah, probably that answer is right. I'm pretty sure the answer. So Brooke wrote is right. Actually, I have the values here. Okay, 0.47 something. 47 something is right. As I'm trying to say, as long as you can get one value, then you should be able to get all other values. Okay. I will give you the table in here. Okay, and that's why I insisted using 1.1, 1.0, and so on. It's because I have handy values. Okay. Again, I'm going to repeat. The limit is determined by the values of the function to the right of 1, very close to 1, very close to 1, getting closer and closer to 1, and not equal to 1. Okay. If you know how to evaluate the function at 1.1, then you should be able to evaluate the function at all other numbers. I'm not looking for all these values. I want you to identify. You remember what I told you in the definition of the limit? I'm looking for as x approaches 1 from the right. So that makes sense. These values approaches 1 from the right, very close to 1, getting closer and closer to 1. As x approaches to 1 from the right, the function values approaches what number? Answer my question, please. What number the values of the function approaches when x approaches 1 from the right? 0.5 is right. 0.5 is right. So do you see 0.5? The numbers in the column on the right, in the second column, are getting closer and closer to 0.5. that number is the limit. That number is the limit. Okay. So we say the limit of the function, this function as x approaches 1 from the right, is equal to 0.5. That value is the limit. So do you see these values getting closer and closer to 0.5? I'm going to repeat the meaning of my notation. Okay. The limit is defined as x approaches 1 from the right. As x approaches 1 from the right, the function approaches, or the function values approaches 0.5. It's not any particular numbers on this list. It's the number the list of numbers approach to. So that makes sense? You see 0.5. You see the limit is 0.5, right? Okay, so we have seen this limit. For the left-hand side limit, I really do not think I need to redefine everything. But if you really want, I can modify the definition in here. Okay. Now look at the definition here. Wherever you see right, you replace right with the left. So can I just modify everything from here to give you the definition of the right-hand side, the left-hand side limit? The left-hand side limit is using that notation. We say the limit of the function as x approaches a from the left. This means the values of the function approaches the number L. The number L is 0.5 in the other case, as x approaches a from the left. And then if you want to modify the comments, it means the limit of the function as x approaches, wherever you see right, you replace right with the left. Okay. It's determined by the values of the function not at a, so not equal to a, greater than a. You replace greater than a probably with less than a. Whatever, I wrote to this, less than a, okay, or to the left of a. You really do not have to copy. Wherever you see left, you replace left with right. I think that's probably the definition I want to give you for the left-hand side limit. And by the way, we also call the limit left-hand side limit. Left-hand side limit, okay, as the limit of the function as x approaches a from the left. Okay. After this, we are ready to do some questions. We'll work on this question. Okay. We'll work on this question. Still, you'll form a table with two columns. Label the column on the left using x, label the column on the right using the function. So this time I'm not going to introduce the f notation. I just write the function. Yeah, the same thing. Right. Okay, now the most important thing is how to choose a list of values. Recall my comments. The limit is determined by the values of the function to the left of 1, not equal to 1, very close to 1, and getting closer and closer to 1. I made 4 comments. And by the way, the 4 comments are all independent. I mean, they have all different meanings. Anybody want to tell me the first value you want to choose? So please, anybody just imagine a number line. So the origin is here, 1 is here, we want to choose a number, so somewhere here, right? Very close to 1, to the left of 1. So please, anybody want to tell me a first number you want to choose? The first number you want to choose, please. .5 is okay. 0.5 is to the left of 1. Yeah, probably you want to use a number a little closer. Can I use 0.9? Sorry, I want to start with 0.9 because I have handy values. 0.9, so that makes sense. 0.9 is less than 1. It's to the left of 1. Very close to 1, right? It's pretty close to 1. Okay. Yeah, and then I want to use 0.99 probably. Okay. 0.5 is okay. It's also okay to start from 0.5, but eventually you want to choose some numbers really close to 1. 999. Can I use the next number 0.9999? Okay. Okay. Again, I want you to get me at least one value of the function. So maybe you try to evaluate the function at 0.9, and that way the function is indeed defined as 0.9. Okay. Get me one particular value of the function at 0.9, please. You need to use a calculator to evaluate 0.9 minus 1 and then 0.9 squared minus 1. That's how you get the value of the function at 0.9, right? I'm looking for the question mark. So please, anybody? Now get your calculator, press some buttons, and get me the value of the function at 0.9, please. Anybody? Are working? Yeah, probably you don't bother. If you don't bother, it's okay. As long as you know what to do, it's fine. Okay. I have a handy value for the. So did you get 0.52 something? I will copy this thing on the. I will copy this the table to the PowerPoint. That's the table I'm talking about. Okay, I will use the table to cover the white thing. Again, the x column has 4 x values to the left of 1, very close to 1, getting closer and closer to 1, and not equal to 1. I'm going to repeat the 4 things over and over later. That's actually the key to determine the limit. Okay, using the table, anybody want to tell me the limit of the function as x approaches 1 from the left? The limit of that function as x. The limit of the function as x approaches 1 from the left. So please. Yeah, 0. Anybody want to tell me the limit, please? It's probably too simple.
Wait,
yeah, 0.5 is right. It's still 0.5, right? I want to repeat this. You see, as x approaches 1 from the left, now look at the mouse cursor, as x approaches 1 from the left, the values of the function approach a particular number. The particular number is, these numbers are getting closer and closer, eventually getting very close to 0.5. 0.5 is the limit, right? So the left-hand side limit is also 0.5. I also want to repeat how to read the notation. It means the limit of the function as x approaches 1 from the left is equal to 0.5. Okay. So that's the limit. That's the central concept. That's the fundamental concept in calculus, according to my slogan. Okay. the next definition I want to show you is probably on this list. Okay. Okay, I do not have to look at this list. We do not look at that list. Okay. For the same function, we have computed the limit of the function as x approaches 1 from the left. We have seen the limit of the function as x approaches 1 from the left, right? So basically, I was trying to say we have seen two one-sided limits. In general, I'm trying to say something in general. Not listen to me. In general, if the two one-sided limits are equal, then we say the limit is the same number. In this particular case, so because we have seen the limit of the function as x approaches right from approaches 1 from the right is equal to 0.5. We have also seen the limit of the function as x approaches 1 from the left is also the same number, so 0.5. These two numbers are equal. Okay, these two numbers are equal. When the two one-sided limits are equal, it's not always the case. We're going to see later. Probably we don't have time to see it. We don't have time to see now. I'm trying to say it's possible for these two one-sided limits, to be different. But when they are equal, when two one-sided limits are equal, and then we say the limit of the function as x approaches 1 is equal to the same number. By that we mean the limit of the function, it means the limit from either side. Can I say that way? If the limit from either side are equal, if limit from both sides are equal, then the limit is the same number. If the two one-sided limits are different, then we say the limit does not exist. We're going to see some cases when the limit does not exist soon. Okay, so not today, next week. I was trying to say it's because two one-sided limits are equal, so 0.5, the limit of the function is also 0.5. If you look at the handout, I was trying to answer that question, to answer the third question. Okay. I will copy it to the PowerPoint. The limit of this function as x approaches 1 is equal to 0.5. So because the two one-sided limits are equal, as x approaches 1 from the left is equal to 0.5, and the limit of the function as x approaches 1 from the right is also 0.5. So these two circled numbers are equal. Okay.